All right, good afternoon, everyone. I'd like to welcome you to our second webinar of the MICA Approved Project Presentations. And today we were joined here by Oliver Wang from Pithis Technology. Oliver, am I saying that correctly? Is it Pithis or Pithis?
Pithis.
Pithis. Okay, we'll go with Pithis. There you go. Thank you, Oliver. Okay, but before we actually go into the presentation, I want to just give you the title of the presentation that we'll be hearing soon. It's Underground Positioning Systems and its Application for Autonomous Automation and Mining Safety. This is definitely a topic of interest to many mining companies. As you know, underground positioning is a challenge for the mining industry, so we're very excited to hear what Oliver has to share with us. I want to also give everybody a heads up as to what other technologies we're going to be speaking to you today about. Today's presentation is going to be on the presentation by Aposis Technologies, which is actually now called Pithis. So you know, it's the first one on the list here. And we will be hosting the other webinars throughout the week as well. I also want to ask you to please, use your phone if you want to click on the screen here. This is the information on the second call for proposals. That's actually open right now. So right now we've got our second call for proposals open, and you'll be able to submit an application into the second call through this link. Of course, there's some membership requirements that come with it as well. All right, so now it gives me great pleasure to introduce you to Oliver, who is going to give us a presentation on the underground positioning system and its application for autonomous automation and mining safety. Oliver, please go ahead. Thank you.
Thank you. Thank you, Charles. And thank you, MICA, give us this opportunity to present our technology. So I want to share a screen right now. So our technology is the underground positioning for mining safety, mining positioning, navigation, routing, and self-driving. So today, myself, Oliver, and Fernando, our CTO, will do the presentation. So here's the agenda. We're going to introduce the technology, the company, and the problem, and the applications of the technology. So Aposis is a spin-off company from Aposis in this February. This company is dedicated to working on the R&D of underground positioning system, and the Aposis inherited the network and the business opportunity from Aposis, and we have a diverse team in technology development, business development, and the mining engineering development. So we collaborate the mining companies from the world, and we complete our prototype testing at NOCAT in October, and we are working on for the field demo at a customer facility now, and it should be ready very soon. So this is our team, myself, CEO, and I have an engineering background in aerospace industry, and Fernando, CTO, PhD student at UPC, Spain, and George, he's a mining product expert, has been working on many mining equipment in this industry, and Steve is a PhD student in aerospace engineering in Princeton University. So we all know the positioning in underground is a challenge. There's no GPS satellite signal available. The magnetic field is not reliable, And the radio usually has a small range, and the accuracy is far from the requirement for many applications. And the initial, some sensors are drift by time and also very expensive if you want to have a high accuracy. And so current solution in the market is something between 5 meter to 6 meters, but in real life, it's up to 50 meters. So many existing solutions rely on the support from infrastructure. So this is our solution. We have a we are using the LiDAR technology to develop the underground positioning system, and this technology can bring to the positioning accuracy up to centimeter level. So this system can work without any need, any support from existing infrastructure, and it can provide a personnel and equipment positioning. And our goal is to make available for self-driving underground. So we already found many applications. Right now, we are in a conversation with an Australian mining company. They want to use our system technology to provide the positioning for the electrical vehicle and the navigation plan for the vehicle underground. And they want to work with us for the eternal goal, the autonomous driving. We also we have another conversation with a UK company. They want to know the position for the miners and the workers underground, so they can see the worker from their surface control office. Another application is for inspection localization at a switch for the robot purpose. So there could be more application more than that. We can use for safety, for personnel, vehicle, data logging of the equipment and sensor, equipment automation, navigation planning, and assistant driving system, and also the autonomous driving for mining vehicles. So what do we want from MICA network? We are looking for a specific mining application to use our technology. We like to build a partnership with you and implement the field testing and the product demonstration. So we are seeking the strategic partner in investment and development. So Fernando will introduce the technology of our system.
Hello, everyone. My name is Fernando, and I will be, like Oliver said, presenting the technology part of the project. So, oh, sorry. There we go. Okay, so basically, as Oliver said, the prototype that we're building, or the product that we're developing right now, is responsible for doing three-dimensional mapping with the technology of a LiDAR, as well as inertial measurement units that basically tells us the predicted drift that the object or the thing that is tracking has moved. And we are building this on top of the ROS ecosystem, And for anyone who doesn't know, ROS is basically the robotics operating system. And it's an open source sort of package repository with a bunch of applications in all sorts of different robotics fields. And right now we're using, well, the LiDAR, the IMU, and on the ROS network. And basically our current product can provide very accurate maps of up to 10 centimeters cubed in mining environments of up to 500 meters squared. And we, as far as we know, this is the only way to localize underground correctly or within a good margin is with LiDAR technology, which is what we're using. So here I have a small video of how the mapping actually works. And this is being done online. So basically I recorded my screen while I was making a map of my apartment. And as you can see, the update rate is very fast. I'm running this current mapping session on my computer, but it can be run on any kind of portable computer or even stuff like the Jetson Nano or other small computers that don't need a screen to be ran. And basically this is the algorithm that we're using, the thing we've been developing for the past few months. And as you can see, as soon as I move into a new space, it creates the missing points in the map. And yeah, this is my work so far has been basically this. As Oliver mentioned, also we had the opportunity to go test the product in an actual mining environment. So we went to a mine in Sudbury, Ontario. Well, it was actually a mining test facility where people go with all sorts of innovative products and sort of get their real mining experience with their software or their hardware. And basically the mining results really surpassed everyone's expectations because we were used to doing only small environments, although we did a much bigger one with very accurate results. And I think actually it played better for us because the bigger the space, the more points we can have and the more accurate the map looks. And these are the samples of the resulting map. As you can see, well, this is around a 300 meter long shaft. So overall, this is a very, very good sized map, and it's very coherent with the actual underground sort of maps that they have at the mine that were done by humans with measuring instruments. This is more detail of the walls of the cave or the mine, sorry. Basically, this is a top-down view, but in a minute you will see a more like sideways view. So here we have the two shafts. This is the floor, and the green dots are the walls. So you can see there's a lot of points in the walls because that's sort of the center of the sensor. So the closer you are to the sensor, the better the resolution of the map. And this is inside the shaft. So these blue points in the top are the ceiling. The green ones and the green ones down here are the walls in the bottom. And this is just more demonstrations of how it looks like. And this is a visualization that I did using a rendering software of the actual map, and just to sort of show how it looks like from a close-up view. So yeah, it's a very good quality map for industry standards. And also this was done in about 2.5 minutes of trajectory, so we can move at a decent speed and still have an accurate map. This is another demonstration of what it looks like inside. And basically, the positioning part of the system, the positioning part of the algorithm, does scan correlation. So given this built map, it actually will try to match the points that it sees with the points that it has already recorded. So it's doing matching with the stuff that it already saw before. And the past, well, the last few months, the more recent months, I've been working on some meshing experiments, basically turning a point cloud, 3D point cloud, into a 3D mesh model using different algorithms. And the idea is to create a more intuitive representation of the space that we're surveying, so that the mining engineers and everyone in the mine has a has a more human-friendly map to look at and to localize themselves in. And this is the resulting mesh that we currently have. And we're also improving this every week. We were adding texture to it. We were trying to make it look less distorted in some parts that were less dense in the point resolution. But as you can see, even just as a beginning software, this is very, very good already. I think it represents the mine pretty well. The walls are the part that I'm most proud of because they reflect the small kind of changes in the wall, the way that the mine is actually looking in the real life. And well, this is a visualization again of the way it looks like. And this is a visualization of the mesh and the point cloud. The point cloud being the map that I showed at the beginning, although now the pixels are a bit bigger, so you can see them better against the mesh. And this is what it looks like in all cohesion. So yeah, basically the meshing algorithm kind of does its best to interpolate between points and create triangles. And this is the software that people use for any type of sort of meshing purpose for video games or for other applications. And then another part of the project that I'm proud of is doing the maps offline. So you basically have the robot moving around the mining environment, recording only, and then you can use a recorded data afterwards and make the maps. So this is an example of the data recorded and then the algorithm being applied to it afterwards. So we can do what is called offline mapping, which is a very big bonus in case we change the algorithm later on. We still can use the same data to do better maps. And we can also try out new stuff that's coming out or changes that we've made to the software time and time again, which is very convenient when you have, for example, some places are not that easily accessible. They might be far away. You might have to pay to go to the mine, stuff like that. So our idea is to record the data once and then do many maps afterwards. And as you can see, the quality is the same as before. It's just being done offline. And okay, Oliver, do you want to take over? You're muted.
So yeah, so in the past year, past 2 years, we developed a system from idea, and right now we finish the MVP testing, and we complete the optimization for map generation, and we are now work on the improvement of localization algorithm. So by early 2023, we are ready for the product demo and also field testing at a real mine. And so from there, we will continue our development for the multi-unit mapping and interaction. And so I think the goal, we want to make the product for some specific application, including the long-term goal for the autonomous driving. So thank you so much. And yeah, any questions, please?
Oh, for sure. Thank you so much, Oliver, and thank you so much, Fernando, for the presentation. Again, you know what, this is definitely a game changer for the mining industry to be able to have a reliable way to locate assets in the environment using this GPS methods that you have here developed. Question I've got for you is, oftentimes when I'm talking to mining companies, they always tell me that, oh, someone else is offering a solution like that one. So you tell us, Oliver and Fernando, what makes your solution different from what is already out there? What is the unique differentiator that sets your solution different from the others that are out there?
I think the first thing, we don't, many current positioning solution in the market, they need a support from infrastructure. For example, they need a Wi-Fi, they need some Bluetooth, there's some need a radio support, but we don't need it. So with that means our system will be able to work in the old mine, which doesn't have any existing infrastructure. And the second one, the accuracy is unbelievable. So that will support many applications I can see. So Fernando, you have any additional? You're mute.
Thank you. Yeah, I also wanted to mention that given the fact that we are developing the software ourselves, we can also cater to the needs of the different mining companies that want to try our product and make the maps suited to them, to their necessities. And also the product is completely portable, so it can be attached to any kind of vehicle, or it can even be attached to a person if they have the correct sort of frame set for it. So it's very portable. And yeah, we provide everything also end to end. So they don't have to basically connect to anything. They just have to run the application and everything is done for them.
Okay, that's awesome. Thank you for that answer, Fernando. Fernando, and don't mute yourself, please, because I don't want to unmute you again. All right, so I'm going to open the floor up to other questions as well. Please go ahead and unmute and ask the question.
Hi, thanks, Oliver and Jose. That was very interesting. So I was just wondering, what other applications do you have for UGPS? Do you have any use cases in other industries?
Right now we have one use case with mining Australian mining company. They want to put our unit onto their electrical vehicle, mining vehicle, and get the location, get a position of those vehicles, so they can monitor the movement of the vehicle. So another application is personal localization, and that's from UK, and they want to know where is a miner located in underground mine. They don't care about like a very accurate, but they want to know which section they are right now in, and also they want the miner also want to know their location. So that means both, not only for the control room, but also for themselves. So for other industry, we got a civil engineering project. They have a robot to inspect the underground sewage, and but the problem is they can do the inspection, but they don't. When they find some defects, they don't know where the defect located. So they wanna put the position, associated with those inspection details. So, but to learn more, so more application I can see, yeah.
And in all those cases, you don't need any support infrastructure and resources from the end user as well.
That's right. So that's the purpose. So we don't. I know the underground mining is so big, the cost will be huge. So that's why we want to bring some innovation to work without infrastructure support.
That's incredible.
Yeah, thank you.
I would like to ask a question around the ROI of your solution. Do you have any quantifiable results? Maybe you can share some of the pricing models for the solution, if possible.
So I think that depend on specific applications, and if you're interested, you have my email, my phone number, and just please connect me. And Charles has my contact information as well. So give me a call, send me email. We can discuss further.
Okay. Yeah, Oliver, maybe just to follow up on that question that was just posed. If you're going to convince a mining company to buy your solution, right? And if the mining company says, "Hey, Oliver, I'm running a business here, right? Are you going to save me money? Are you going to make me money? Like, what's your response to a mining company that says, Oliver, tell me, are you going to save me money? Are you going to make me money? How would you answer that question with your technology?
So I think two things. One is what's their urgent need? Do you want to improve their safety? And so this is a solution. So do they want to improve the operation efficiency? So we can work on that application. For example, the route planning. So because the vehicle, every vehicle can have our unit, and they can talk to each other, and they know, what is the best way to go through driving in the mine. So that will improve their operation efficiency. In this case, they're gonna save money, and they're gonna save time. So, but that depends on the application. We can build a business case and give them the information.
Thank you. Thank you for that, Oliver. Maybe, Oliver, I'll ask you one more question from my end here. Is what would you say is the speed of installation of your solution? How quickly can you get it up and running in a company?
I think it also depends on application, but if just for safety, purpose of the equipment or vehicle or personnel, that we can count as a simple application. That will be quick. But if they want to implement the navigation function, the route planning function, that will be a different case. So, and also depend on the size of the mining facility. So manufacturer will play in this case.
Okay, thank you very much for that. Maybe I have room for one more question before we end this presentation. Any more questions? All right. Okay, we're good. There's no more questions there, Oliver. Oliver, I just want to take a moment to thank you again, you and Jose, for your presentation, and looking forward to hearing more about your solution as you develop it out. Thank you again, guys. I'm going to stop the recording now.
Thank you.
Thank you so much.